I am often asked what existed before the Big Bang, as if the universe were a story that must have a first page, a silent prologue hidden somewhere behind the opening line. But to ask what came before the Big Bang is to confront the deepest limits of human intuition, because our minds are shaped by cause and effect, by beginnings and endings, by clocks that tick forward, and memories that look backward. Yet the universe does not promise to respect the way we prefer to think, and when we follow the mathematics honestly, without comforting metaphors, we discover something both unsettling and beautiful, namely that the question itself may be misguided, for time as we experience it may not have existed in any meaningful sense before the Big Bang, because time is not an external stage on which the universe performs, but a property that emerged with the universe itself, intertwined with space in what we call spacetime, and according to Einstein's general theory of relativity, space and time form a dynamic fabric that can stretch, curve, and evolve. And when we trace this fabric backward using the equations, we find that distances shrink, temperatures rise, and the density of the universe increases without bound, until the mathematics appears to break down at what we call a singularity, a point where our current theories lose their predictive power. And for many years this singularity was interpreted as a literal beginning, a moment of creation where the laws of physics were suspended. But I have never been satisfied with the idea that the universe requires a loophole, a special exemption from its own rules, because the purpose of science is not to insert miracles where understanding fails, but to extend understanding so that miracles are no longer needed. And this is why I proposed, together with James Hartle, what is known as the no-boundary proposal, which suggests that when we combine quantum mechanics with gravity, time near the origin of the universe behaves more like a spatial dimension than a temporal one, meaning that the universe does not have a sharp edge or boundary in the past, just as the surface of the Earth does not have an edge at the North Pole. And to ask what lies north of the North Pole is not wrong because the answer is hidden, but because the question no longer applies. And in this view, the universe did not spring into existence from nothing in the conventional sense, nor did it sit eternally waiting for a trigger. Instead, it is self-contained, finite yet unbounded, governed entirely by the laws of physics. And this reframes the idea of before the Big Bang into something more subtle. Because if time itself emerged from a quantum state where the distinction between past and future dissolves, then there was no classical before for anything to exist in, only a smooth transition from a timeless quantum regime into the expanding universe we observe today. And this does not mean that physics has nothing to say about the origin. On the contrary, it suggests that the origin is a physical process, describable in principle, not a metaphysical mystery beyond inquiry. And when we examine the early universe through the lens of quantum cosmology, we find that fluctuations at unimaginably small scales could have seeded all the structure we see today, the galaxies, the stars, the planets, and even ourselves, arising from tiny variations in a primordial quantum field, amplified by a brief but violent period of expansion known as inflation. And inflation itself may not have been a one-time event, but part of a much larger and stranger picture, where different regions of space undergo inflation at different times, creating a vast multiverse of bubble universes, each with its own physical properties. And in such a scenario, the Big Bang is not the absolute beginning of everything, but the beginning of our local region of space-time. Much like a sunrise is not the beginning of the Earth, but the beginning of a day from a particular point of view. And this idea naturally leads to the question of whether something existed outside or before our Big Bang. And here we must be careful, because words like outside and before are rooted in classical intuition. Yet the quantum universe does not always honor such distinctions. And while some models suggest a pre-inflationary phase, or even a previous contracting universe that rebounded into expansion, what is sometimes called a bounce, others imply that the universe is eternal in a quantum sense, without a single moment of creation, constantly fluctuating birthing regions like ours, through processes governed by probability rather than necessity. And none of these ideas require a moment when the laws of physics were switched on. They require only that the laws themselves are fundamental and complete, capable of describing not just what happens within the universe, but how the universe comes to be. And this brings us to the most provocative implication of all, because if the universe can arise spontaneously from a quantum vacuum as quantum mechanics allows, then the total energy of the universe can be exactly zero, with positive energy and matter balanced by negative energy and gravity. And in such a case, the creation of a universe does not violate any conservation laws. It is not something that requires an external agent to initiate it, and this does not strip the universe of meaning, as some fear, but rather places meaning within the universe itself, in the patterns it forms and the questions it enables us to ask. And when people hear that the universe may have come from nothing, they imagine an empty void, a silent darkness waiting to be disturbed. But the quantum nothing is not nothing at all. It is a seething arena of potential, governed by mathematical laws where particles can appear and disappear, and space-time itself can fluctuate. And from this perspective, the Big Bang is not the creation of the universe from absolute nothingness, but a transition from a quantum state without classical time into a universe with time, history, and causality. And this is why I say that asking what existed before the Big Bang may be like asking what caused the laws of mathematics to be true. It assumes a framework that the answer itself dissolves, yet this does not close the door on curiosity, it opens a deeper one, because it challenges us to understand how the laws of physics select the universe we observe, why the constants of nature take the values they do, and whether these values are inevitable or contingent. And as we pursue these questions, we are reminded that science is not a search for comforting answers, but for honest ones. And the honest answer to what existed before the Big Bang is that the universe may not have had it before in the way we imagine. That time itself may have begun as a consequence of the universe's quantum origin, and that the true wonder is not that there was something instead of nothing, but that the something we inhabit is intelligible, governed by elegant laws that the human mind, a product of that same universe, can partially grasp. And if there is a lesson to be drawn from this, it is not that we should abandon our questions, but that we should refine them, because the universe is under no obligation to make sense on our terms. Yet remarkably, through science, it often does. And in that fragile alignment between human reason and cosmic order lies the real miracle, not hidden before the Big Bang, but unfolding every time we dare to understand. If we accept that the question of what existed be, for the Big Bang dissolves when time itself becomes a physical quantity rather than a background stage, then the natural next step is to ask an even more unsettling question, namely whether the universe was inevitable once the laws of physics existed, or whether our cosmos is merely one outcome among countless possibilities. And this question pushes us beyond the comforting image of a single, finely tuned universe toward a far stranger picture in which reality itself may be plural, probabilistic, and deeply indifferent to human expectations. Because when we explore the early universe using quantum theory, we find that certainty gives way to probability, and the universe is no longer a single predetermined history, but a superposition of many possible histories, all contributing to what we observe today. And in this framework, the Big Bang is not a unique event with a single outcome, but a branching point, a quantum transition in which many universes could emerge, each governed by slightly different laws, constants, and dimensions. And this idea, often associated with the multiverse, is not a speculative escape from ignorance, but a natural consequence of taking inflation and quantum mechanics seriously, because inflation, once it begins, is extraordinarily difficult to stop everywhere at once. As a result, it may continue eternally in some regions of space, constantly spawning new bubble universes, each with its own Big Bang-like beginning. And from within any one of these bubbles, observers would perceive their own origin as a singular creation event, even though on a larger scale it is merely one episode in an ongoing cosmic process. And this radically alters how we think about origins, because it suggests that the question is not why the universe exists, but why we find ourselves in this particular universe with these particular laws. And this brings us to the anthropic principle, a concept that has been both misunderstood and unfairly dismissed because it does not claim that the universe was designed for us, but simply observes that any universe capable of being observed must be compatible with the existence of observers. And in a multiverse where many different physical conditions are realized, it is not surprising that we find ourselves in one where galaxies can form, stars can shine for billions of years, and chemistry can give rise to life. And this perspective does not cheapen the universe, as some critics argue, but rather explains its apparent fine-tuning without invoking purpose or intention beyond the laws of physics themselves. And yet, even this explanation raises deeper questions. Because if the multiverse exists, what determines the underlying laws that govern it? Why quantum mechanics has the structure it does? Why gravity behaves the way it does? And whether there is a final theory that unifies all forces and particles into a single mathematical framework. And this search for a theory of everything is not motivated by arrogance or a desire to play God, but by the recognition that the universe, at its most fundamental level, appears to be governed by simple, elegant principles. And history has shown us that when nature can be described by a simpler theory, it eventually will be. And it is possible that such a theory, once discovered, will reveal that the existence of a universe like ours is not merely possible but unavoidable, that given the laws of quantum gravity, universes will spontaneously arise, evolve, and decay as naturally as waves form on the surface of the ocean. And in that case, the Big Bang is not a mystery demanding a cause, but a consequence of deeper laws. And this idea has profound implications for how we think about creation, because it replaces the image of a universe brought into being at a single moment with that of a cosmos that is self-generating, self-organizing, and self-explaining. And this does not mean that all questions are answered, because science does not eliminate mystery, it refines it, pushing it to deeper levels where new questions emerge, such as whether the laws of physics themselves evolve, whether different universes can influence one another, or whether information can pass between cosmic regions in ways we have not yet imagined. And this leads us naturally to the concept of information, which may be more fundamental than matter or energy, because in modern physics, particularly in the study of black holes, we have learned that information is never truly destroyed, even when matter falls into a black hole. And this insight suggests that the universe, at its deepest level, may be a vast information processing system, with space-time particles and forces emerging from underlying quantum bits. And if this is the case, then the origin of the universe is not simply the beginning of space and time, but the beginning of a particular pattern of information, a cosmic computation unfolding according to precise rules. And this view has the remarkable consequence that the universe is intelligible not because it was designed to be understood, but because understanding is simply one of the things it does. And conscious beings like ourselves are not accidents tacked on to an otherwise meaningless cosmos, but natural expressions of the same laws that govern galaxies and black holes. And when we consider this, the question of what existed before the Big Bang transforms once again, because it is no longer about objects or events, but about laws, structures, and possibilities. And it may be that the ultimate answer is that there was no prior state in the conventional sense, only a timeless mathematical structure capable of giving rise to universes, and observers. And this idea, sometimes called mathematical realism, suggests that the universe exists because the equations that describe it are consistent, and that existence itself is a property of mathematical coherence. And while this may sound abstract, it is in fact deeply rooted in the history of physics, because time and again we have discovered that the universe behaves as if it were written in the language of mathematics, and that by uncovering these equations, we are not inventing reality, but uncovering it. And if this is so, then the Big Bang marks the moment when this abstract structure took on physical form, when possibility became history, and when a universe capable of asking questions about its own origin came into being. And from this perspective, the most astonishing fact is not that the universe began, but that it can reflect upon its beginning. That atoms arranged by blind physical laws can contemplate the origin of space and time. And this, to me, is the deepest significance of cosmology, because it shows that understanding the universe is not a detached intellectual exercise, but a way of understanding ourselves, our place in the cosmic story, and the fragile conditions that make thought, curiosity, and meaning possible. And as we continue to explore these ideas through observation, experiment, and theory, we must remain humble, because the universe has repeatedly shown that it is stranger than we imagine. Yet we must also remain bold, because every major advance in our understanding has come from daring to ask questions that seemed absurd or unanswerable at the time. And so the next chapter beyond the Big Bang is not written in fire and light, but in equations, probabilities, and ideas. And it is a chapter that humanity has only just begun to read.